Assalamu alaikum students. Welcome to my YouTube channel and today we will discuss about Newton's law of motion. न्यूटन एक अच्छा इंसान था हम उसके बारे में स्टडी करने वाले हैं न्यूटन्स लॉ ऑफ मोशन द थ्री स्टेटमेंट डिस्क्राइब द रिलेशन बिटवीन द फोर्स एक्टिंग ऑन अ बॉडी एंड मोशन ऑफ द बॉडी first formulated by English physicist and mathematicians Isaac Newton, which are the foundation of chemical mechanics. Newton's first law, the law of inertia, which is also called a Newton's first law, states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by force. In fact, the classical Newtonian mechanics, there is no important distinction between rest and uniform motion in a straight line. They may be regarded as the same state of motion seen by different observers on moving at the same velocity as the particle and the other moving at constant velocity with respect to the particles. The postulate is known as the law of inertia. The law of inertia was first formulated by Galilei for horizontal motion on Earth and was later generalized by Ron Descartes. Although the principle of inertia is the starting point and the fundamental assumption of classification mechanics, it is less than initially obvious to be untrained eyes. In Aristotelian's mechanics and in ordinary experience, objects that are not being purchased tend to come to rest. The law of inertia was deduced by Galileo from the experiment with balls rolling down inclined planes. For Galileo, the principle of inertia was fundamental to his central scientific task. He had to explain how it is possible that if Earth is really spinning on its axis and orbiting the Sun, we do not sense that motion. The principle of inertia helped to provide the answer. Since we are the motion together with Earth, our natural tendency is to retain the motion. Earth appears to us to be at rest. Thus, the principle of inertia, far from being a statement of obvious, was once a central tissue of scientific contention. By the time Newton had stored out of all the detail, it was possible to accurately account for the small deviations from the pictures caused by the fact that the motion of Earth's surface is not uniform motion in straight line. In this Newtonian formulation, the common observation that bodies that are not pushed. By the time Newton had stored all of the detail, it was possible to accurately account for small deviations from these pictures caused by the fact that the motion of Earth's surface is not uniform in straight line. So, Newton's second law, F is equal to ma. Newton's second law is quantitative description of changes that a force can produce on the motion of the body. It said that the time rate of change of the momentum of a body is equal in both magnitude and direction to the force imposed on it. The momentum of a body is equal to the product of its mass and its velocity. Momentum like velocity as a vector quantity having both magnitude and direction. A force applied to the body can change the magnitude of the momentum or its direction or both. Newton's second law is one of the most important in all physics. For a body whose mass m is constant, it can be written in the form F is equal to ma, where F and a acceleration are both vector quantities. If a body has a net force acting on it, it is accelerated in accordance with the equation. Conversely, if a body is not accelerated, there is no net force acting on it. And now the Newton third law of motion. And Newton third law states that when two bodies interact, to apply forces to another that are equally in magnitude and opposite in direction. The third law is also known as the law of action and reaction. The law is important in analyze problem of static equilibrium where all forces are balanced. but it also applies to bodies in uniform and accelerated motion. The force it describes are real ones, not more backkeeping devices. For example, a book resting on a table applies a downward force equal to its weight on the table. According to the third law, the table applies an equal and opposite force on the book. The force acting because the weight of the book caused a table to deform slightly, that is pushed back on the book look a coiled spring. Okay, if a body has a net force acting on it, it's undergo accelerated motion to accordance with the second law. So this was our topic. Hope you will understand. In the next lecture we will discuss some other topics. Hope and subscribe my channel. Allah Hafiz.